Good morning, Dave Kenworthy here. It's the 29th of the 12th, 2021, and today we're going to look at something that's happening on academia. There's a big discussion going on about this analysis of the Giza Plateau by Jim Wakefield, and he's discovered this this diagram based on the relationship between the Great Pyramid and then the Small Pyramid here. I'm not sure of the name of that one. It begins with an M, but he's put this rectangle together, and there's a quarter of the Great Giza Pyramid base in it, and there's a quarter of the Small Pyramid base in it. And he's worked out that the area of the third pyramid is 356.5 imperial feet, and it's 1/36 of the area of the rectangle, and the base of the Great Pyramid is 1/8 of the area of the rectangle. Now this calculation here, this 356,499, obviously 356.5, is an astronomical cycle, and it's related to the moon. And Jim's done loads of work around astronomical cycles, and he's had a paper published and accepted by the European Association of Archaeologists. So he's got great experience in this kind of work, and I'm quite prepared to accept that this rectangle is something that we should be studying and that it's got great value. And the reason why I think that is because Jim has copyrighted it. Now that is really something to do. He must be very confident when he's copywriting something like this, and it's giving us great insight into what's happening on the Giza Plateau. And what I noticed when I first saw this was that this area here is a quarter of the base of the Great Pyramid, and this area here is a quarter of the base of the small one, and they're both included in the rectangle and the rest isn't. So I was wondering what the relationship was between that and the rectangle, and that is 1/144th of the area of the rectangle, and that is 1 divided by 32 of the area of the rectangle. And we're already looking at 32 here when we multiply the length of the sides of the rectangle, 2.5 times 3.2 equals 8. The whole thing, to me, seems to be stacking up perfectly. And what I really like about this is Jim's using cubits without actually telling us what the lengths of the cubits are until he finally works out the astronomical cycle of the moon at the end relating to the Small Pyramid. So he's saying that the base of the Great Pyramid is 440 square royal cubits, and we know that's right. It doesn't matter what the size of the square royal cubit is. We know that that's going to be a constant in this diagram that he's showing us, and that they're going to be 1548800 square royal cubits in the total rectangle. And we know when we check his calculations that he's got this right down at the bottom. So that's Jim's work in respect of that. And what I want to marry it with is my work in respect of the actual size of the square royal cubit. And if you look here, I've done exactly the same as Jim, and I've copyrighted this work because I think it is most probably the solution to the Egyptian problem of 2 square Riemann equaling 1 square royal cubit, and they do, because there's the Riemann in this calculation, and there's the 2 square Riemann, and there's the square royal cubit, which is just Jim's royal cubit of 20.625, and Harry Sivertson and John Neal and Michelle's royal cubit of 20.6181818. And interestingly, these cubits in fractional notation, one is 20412 divided by 990, that's Harry's, and Jim's is 990 divided by 48. So if we multiply them together, we get the Egyptian square royal cubit as 20412 divided by 48, and that's 425.25 square English inches. And I did a lot of work on this when Jim first produced his paper, but in the end I scrapped it because I couldn't get my work to agree Jim's in terms of the the lunar calculation that he'd done at the end. But I'd made a mistake in my calcs anyway when I went to look back at them, so I scrapped it for the wrong reasons, but never mind, I've resurrected it now. So let's have a look at the calculations that are coming out of this. I've called this presentation Academia 1, Jim Wakefield Inner Giza Plateau Rectangle. And the first thing that I've done is reconcile my findings in respect of the 425.25, the DK copyright, and Jim's in respect of the 1548800 for the size of the rectangle in square cubits. If we multiply those two out into square inches, we get this number. And if we divide it by 144, we can turn it into square feet. And we get that divided by that. That divided by 1.144 gives 4573800. Then we divide that by an acre of 43560 square feet. And it comes to exactly 105 acres, and that can't be by chance, because Berryman is telling us that the Egyptians were using acres, they were using the imperial system, and they were using a square royal cubit of 20.625 inches, because that reconciles back to the imperial system. And it does that because if you divide it by 25 and multiply it by 24, you get 19.8 inches. If you divide that by 1.5, you get 13.2 inches. And if you divide that by 1.1, you get 12 inches. So everything reconciles. And we're looking at a royal cubit as Jim is calculating of 20.625 imperial inches. And there's a reason why we're going to get that. Now let's have a look at what these rectangles are telling us. So the inner rectangle in acres that I've calculated using this calculation here is giving us 105 acres. And I've put that in there. And to get to the quarter of the Giza base, we divide by 32. And that gives us 3.28125. Now, if we multiply that by 12, we're going to get the meter that's being used in the design. And these are all in acres, but they can be translated as other units. This always happens when you look at this Egyptian mathematics. So we're dividing now 105 by 144, which is the total number of the small pyramid quarter inside the large rectangle, the Giza Plateau rectangle. And we get this amazing figure, 0.7291666 recurring. And that's Algernon Berryman's second Egyptian digit. That is the Egyptian digit, and he tells us exactly how it's calculated. So what's coming out of Jim's model is, when we put acres in it, divide it by 32, we get the meter in feet. When we divide by 144, we get the digit in inches. So we can look at the digits that we need to arrive at to get to Harry Sivertson's figures, to get to Jim's figures, and to get the figures that I've been using in my analysis of the Giza Pyramid. And when we get 0.729177 in acres and we convert it to inches, we can then, because that's one digit, we can then apply Berryman's analysis of the Giza base, which gives 50,000 digits in the Giza base, and we get this figure here, 36458.333 recurring imperial inches. And this is geodetic analysis, this that we're looking at. Now, to get to Harry's column, this one, we're using 0.729. So we can work that back up to here, and we get 104.976 acres. Divide that by 32, we get 3.2805 as the metre that's working with this column. And we get this 0.729 digit, which when we multiply by 50,000, we get 36450 imperial inches as the Giza base. Now, the cubit that works with that is the geodetic cubit, and we've got to divide by 1760. So B5 divided by 1760 is that. And then we have to divide this one by the same and this one by the same. And we get 3 cubits. It's only when we come to this column, where the number of acres are 105.6, that we're getting the cubit that I'm suggesting is the base 100 cubit. It's plus 100 divided by 4.8, or 1,000 divided by 48, 20.833. And that, multiplied by 0.99, 99% of that, 99 divided by 100, is Jim's cubit. So that's why, I mean, I've done a series of presentations, and I explain why I think that is definitely the Egyptian royal cubit. There are a lot of reasons for it, and also it's why this column is not going to produce the square royal cubit. Now, we're going to complicate matters now, because these geodetic cubits are not producing the cubit lengths that Harry and Jim are suggesting they were using. And the reason for that is these are geodetic cubits, not royal cubits. And to get a royal cubit, we multiply the digit by 20, that's there, and then we multiply that by the approximation for root 2 that Berryman tells us these people were using to produce their cubit, and there it is. So we've got 14.58 as the Riemann, and we're going to multiply it by 140 divided by 99, and we get Harry's cubit. And that gives us a revised Giza base when we multiply by 1760 of 36288, and that's Harry's base that he's telling us that the Giza Pyramid is definitely designed against this. But when we look at the same application for Jim, and remember now, this is the reconciliation here is producing this figure here, and we're getting 0.729177 recurring. It's producing this Giza base that Rena Meg has produced in her calculations, 36458.333, producing this geodetic cubit. When we multiply that by 20, we get 14.5833. Multiply that by 99 over 7, the other version of root 2 that Berryman tells us they were using, we get 20.625. And we get this Giza base, revised Giza base, of 363, less than that. So the geodetic cubit, which is 50,000 divided by 1760, is producing a different Giza base than the royal cubit calculated by using the same digit but multiplying it by 20 and then multiplying it by root 2. And this is what this calculation here is based on, what this 425.25 calculation is based on. That multiplied by that is that. And what Harry has done here, he's just not prepared to accept this column and this column, but everything that he is producing is analysed in this column. Now, what I'm going to show you now is something that I think is conclusive evidence that this column is the most important one, because the mile in inches in Berryman's analysis, although Berryman doesn't realise it, it's there, is 86400 digits. And for Harry, it produces this number of inches in the mile. For Jim, it produces this number. And for myself, it produces 63360, which is the English mile. Now, if we look at Jim's calculation and put it into feet, we can get the difference between these two miles, and it's 1.2 feet. So if we divide that by 1.2, we get 4374. If we divide that, we get 4375, and that 4400. And we know the Giza base, one side, is 440 cubits. And this is the base 100 system, this column. That's 100 divided by 4.8. And this is Harry's signature unit, 105.6. I mean, Harry insists on this, and the reason he insists on this is when you use 1.056, divide it into 528, you get 5,000 of these, what Professor Parker Pearson describes as the long foot. So everything that Harry is telling us is coming out in this column because it's based on 105.6 acres. Everything that Berryman's telling us is coming out in this column because he's telling us they're using the imperial system, and he's telling us they're using the English mile, and we're finding that there are 86400 digits in one English mile. And we're finding that there's a ratio for each column. Harry's coming out at 4374, Jim's coming out at 4375, and the final column is coming out at 4400 as base 100. And this was the calculation that I did to get to the 63360. So we can go back to this. Big deal. It's the solution to the 2 square Riemann equal 1 square royal cubit. And this is something that's been waiting for a solution for a very long time. And it's an original copyrighted new metrology solution. So we can look at... So there we go on that. We'll look at Jim's paper, copyright. I mean, this analysis that Jim is giving us is giving us exactly the same analysis that Berryman's produced in his book. And Berryman's analysis produces the royal cubit of 20.625. And the reason why there's the current metrology and there's the new metrology is the new metrology is recognizing that the system that the ancient designers of the of the Great Giza Pyramid were using base 100, and we can show that by multiplying the cubit by 4.8, because that gives the proximity to 100. So if we multiply And if we multiply, these are the proximities that we're getting from these cubits, that line there and that line there. And the geodetic cubits are longer than the royal cubits in every case. But we get the royal cubits when we use root 2, and we get the geodetic cubits, which are longer. And that's Harry's geodetic cubit, and that's Jim's. And they're producing these two. And this is why the whole thing is so complex and complicated. I mean, we're starting off using acres here in the calculations and using Jim's analysis, which is spot on, because it's producing this analysis. It's working with this 425.25 square royal cubit in inches, in square inches. And this is the point that I'm trying to get over, and you can see how difficult it is because of the complexity of it. Harry's telling me to go back and start doing something else rather than reading Berryman, because Berryman's got it wrong. But in actual fact, it's John Neal in his book, All Done with Mirrors, that's got it wrong, because he's done a real trick at the start of the book, and he said that when Professor Greaves went and measured the foot, the Roman foot, he measured the wrong foot because it didn't give the right result. And when you look at Professor Greaves's actual measurement, it gives a Roman foot of 11.664 imperial inches, and that's absolutely spot on. But Neil has changed it to produce a foot that then produces all the analysis that goes with this column. So I think that is the bit that's wrong here. I'm not knocking John Neal for it, because I think his analysis is amazing, and the way that he's put the book together with all the amount of information in it is tremendous. But I think he's had a go at Berryman for the wrong reasons, and I don't think he realised these root 2 calculations, or that Berryman's first Egyptian royal cubit is 20.6181818 recurring. And the other thing is, we need to be using fractional mathematics, because this stuff can all be converted to fractional mathematics. But it's very difficult to do that. It's much easier to present it using decimal notation. So I'll stop there.